All right, last one for now. This is setting up what we're going to look at next week and backtracking to make sure last week's stuff made sense. We're lifting something straight up. There's our distance, but I didn't give you a force. I gave you a mass, and then there's this mumbo jumbo about moving at a constant speed. If we think back to last week, moving at a constant speed is a trigger in our physics brains to tell us that the forces must be balanced. Gravity straight down, whatever you want to call it, it's a forklift, so we could call it an F applied straight up. If it's moving at a constant speed, those two have to be equal. If one was bigger than the other, it'd be accelerating in one direction or the other. We know that Fg is always m times g, so this means that the F is m times g. Work is F times d times the cosine of the angle. The force in this case is mg. Oops, I didn't write it in here, but if we're talking about the forklift's work, then it's the force that the forklift applied. So F applied will go in as our force. The distance that it moves, sometimes we could call that h for height. We don't really have to, but setting up what we're doing next week. And then in this case, since it moved upward and the force was upward, this is another case where the angle is 0. So really this cleans up to work equals mgh. File that away. We're going to use that next week to finish this particular question off. The m was 500. G is always 9.8. And the h was 3. When we calculate that out, that works out to 14,700. The 500 was in kilograms. 9.8 is in newtons per kilogram, so that cancels out the kilograms. The 3 was in meters, so we end up with newtons times meters, which is the same as joules.